So shall I move on to the second?
Yeah. So we're talking now about the population's getting older and the disease.
No, we're talking about vector-borne diseases.
Oh, sorry. Yes.
Because the next way in which people become ill is usually an insect or some small thing like that. And here you're talking about plague, you're talking about typhus, which is carried by ticks, and in some ways the second worst disease afflicting human beings, which is malaria. And these were diseases which grew a little later than the waterborne diseases. They're not quite as old. And they are, again, devastating and in some ways much more fearsome. The other diseases are just perennial, or cholera, not so much, but people have been really frightened. They were frightened of plague, bubonic pneumonic plague, particularly because, firstly, it was a huge killer. I mean, in the Black Death, which was the most famous bubonic plague or pneumonic plague in Britain, up to a half, certainly over a third of the population just died. And of course, the way you died was horrific. You had these great buboes, sort of lumps under your arms and groin, and you died in great pain. And no one could see. It was just mysterious. You know, one day it was in one town, and the next day it was in another town. And the Pied Piper of Hamelin story is, and the rats and so on, is some allusion to this. And it was only very late, the end of the 19th century, that both some Japanese and others discovered the link between bubonic plague and rats and found some cure for it. There'd obviously been some earlier remedies and so on. And the thing about bubonic plague particularly was that it was located, it was endemic in the area, sort of Western China and the Stans, that sort of area, in those deserts where there were lots of rodents and they would have it and harbor it. And then every few centuries, it would break out of there and spread. And there was a terrible one at the end of the Roman Empire, for example, Justinian and around then. And then there was the famous one in the 1340s, which came up. And it's a mysterious illness because the famous one in Britain, which Defoe wrote a book on, the plague, Journal of the Plague Year, 1665, that many people in England died in 1665 of that. And then it disappeared. I mean, it didn't disappear in the world because there were other plagues. There was another one which Albert Camus wrote a book on the plague, a famous book about the 1720s plague, which hit southern France. His book is about southern France. So it came back. But after that, it tended not to come to Europe. There was an outbreak at the end of the First World War, and even people in England, a few people in England had plague in this area. But no one knows why it stopped. It's like most of history. People don't know the answers, they know the questions. And I mean, the most popular theory is that the one way you can stop plague is to stop people moving, a quarantine. So if you have a border, you stop people coming into England with COVID variants, and you won't get the COVID variants. And people realized that there was something to do with the ships coming in. They didn't know it was the rats on the ships or the clothing, but so from the 14th, 15th century, particularly in Italy, because the plague corridor, as it was called, came from Central Asia through Turkey. Turkey had the plague very badly. And then it would come across to Greece and Italy along the Mediterranean in ships. And so from about the 15th century, the Italians started more and more effectively. And right across Europe, they also, when there was news of plague, they would shut the borders. And this may have gradually attenuated.
Did you have it in United States, and did you have it in South America? And
Yes, well, you did, yes, but not as seriously. The other theory, which is quite interesting, is that the bubonic plague is spread by one variety of rat, the black rat. And this was the dominant rat species in Europe and the world until the end of the 17th century. And then another kind of rat, the brown rat, turned up, I think came from Scandinavia. And it was like the grey squirrel, more effective than the red squirrel. It outmaneuvered the black rats. And so the black rats tended to die out. And this may have been the cause. Anyway, I won't go into typhus and malaria, well, except malaria. Malaria is absolutely fascinating disease. Here again, I feel a sort of link to it because the anti-malarial, the discovery of the cause of malaria was made a few miles from where I was born in Assam by a man called Ross in a research station in Assam. And he definitively showed that it was the mosquito. He did the sort of work on it, although the Italians had earlier worked out the connection with mosquitoes. An Italian had put mosquito nets around people and found that they didn't get malaria. So they knew the link, but they didn't know exactly how.
is malaria a killer, or is it a deformer? Because you get these colonies, don't you, and things like this. I mean,
It's a killer.
Yeah.
Terrible. I mean, there are different variants. Some are not absolutely lethal,
Right.
but some of them are absolutely wipe out populations. And it's the biggest problem still, even with COVID, I mean, in many parts of the world, like Africa. But from the early 20th century, you began to get some way of dealing with it. But again, it poses very interesting problems. In relation to Japan, Japan is puzzling because it's ideal for malaria. That is to say, the mosquitoes breed in water, and there's a lot of water and still water. You need still water. They won't breed in rapid water, and they won't breed much in muddy water. It has to be still, clear, but very small. You can have in a coconut shell. That's fine. So Japan had lots of that, and it was warm, and it had lots of mosquitoes. But and it had quite a lot of malaria until about the 12th, 13th century. And then from then on, it was more or less malaria free.
Mm-hmm.
So why? So there are two main theories I know of. One is that the Japanese were extremely good at protecting people when they were sleeping. Most mosquitoes bite just in the twilight, just as the day is receding, and through the night. They feed at night. Now, if you can put a malaria screen around someone, netting, then that protects them. And the Japanese the country was so infested with not just mosquitoes, but many, many kinds of biting and other insects, that the Japanese, who were extremely good with textiles, silk and cotton and other, they from very early on made very, very good netting, which they would put round people. The most famous Japanese novel, The Genji, by Lady Murasaka, has descriptions of the prince and the elite in palaces, going to bed, and they would have their netting draped down round them. And even poor farmers and others would make sure that either the windows or their bedding was protected. So they cut the transmission in that way. And that may be one of the main factors. Another theory is that the Japanese loved goldfish, and they kept goldfish in the pot, in the wells and little ponds and so on. And goldfish eat the larvae. My theory, of course, is that it's tea, because the decline of malaria in Japan exactly coincides with the widespread drinking of tea. Now, if you have a theory like that, the obvious way is then to test it somewhere else. Is there the same association? So we now go to the other end of Eurasia, Britain, and here we find an equal puzzle. It's not widely known that malaria wasn't just a sort of sub-Saharan affliction. Malaria was really serious in European countries, Italy, of course, but much further north, right up into Scotland, right up into Scandinavia.
Right.
Anyone in England knows that there are mosquitoes around, and some of them are not the most serious, the falciparium, but there are other very serious ones. And so right up to the 18th century, England was subject to malaria. It was called the ague,
Okay.
the quotidian every 4 days. You'd start shaking. I mean, you find it in Andrew Aguecheek, no doubt, in Shakespeare, but you find it in literature and so on. You know, people had this disease, and it was particularly prevalent in sort of marshy, less well-drained areas. That is in this area in East Anglia, where I am in Cambridge, around here, and also in the south in Kent and Surrey and along the marshes. These were the two most serious areas. And it went on, and in the bills of mortality, that is the published accounts which were put out in Britain from the later 17th century, which listed the number of deaths each week in London and places like that, and the causes of death. And the causes of death in the early 18th century in London, a high proportion were from ague, from this disease. And then around 1750, Defoe, for example, in his tour, he talks about how it was very difficult to get clergymen in East Anglia because they just died. The average duration of a new clergyman coming to a village in East Anglia was a few years, and then they would die of this disease. The local inhabitants had become somewhat immune to it, but people coming in died. And they were called kill parishes or some such. Anyway, from about 1750, 1760, something extraordinary happened, which was that malaria disappeared. Now, why? A friend of mine, or someone I know, Mary Dobson, is the great expert on British malaria, and she's written books and articles on this. And she put forward a number of theories for this. And one of them was that the fens, the marshy bits, were drained more effectively in this period. Unfortunately, that's not true. The drainage of the fens was the two moments of it were the later 17th century, Vermeulen and others, and in the 19th century. So it doesn't fit time-wise. Her second theory is that there was a housing revolution. Well, it is true that historians talk about a great improvement in housing the end of the 17th and in the 18th century. But it wasn't, I mean, the houses were better built or a different way or whatever, but they weren't protecting against malaria, as I know, because I have double glazing and I, shut doors very carefully. But my house has mosquitoes in, and this barn has mosquitoes in. You can't keep mosquitoes out in that way. So basically, and the housing revolution wasn't around the 1750s. It was either earlier or a bit later. So that doesn't work. A third theory she has is quinine, because the South American Indians had discovered that the cinchona bark was effective in preventing and alleviating malaria. And quinine was certainly brought in increasing quantities in the 18th century from South America. And it was very important in India in the 19th century. It was one of the things that the British took there. But unfortunately, it doesn't work because it was very expensive and only pretty rich people could afford quinine. It wouldn't be a sort of thing that villagers could take. And the final theory she has is that it was to do with the interaction between animals and human beings, that before this, there was much closer proximity, that the houses, as in many parts of the world, would have a part for the humans, and then more or less not separated off would be the byres and barns where cows and often mosquitoes feed off cows and sheep and things, and also of human beings, and therefore they like to be near animals. But again, there's no evidence that there was a part of the agricultural revolution was a distancing of the animals. Animals still lived close by in the way they had done. So, as with many things, you can knock out everything, but then what? And of course, I don't have to tell you.
Tea.
Tea. And I did put it, the leading expert on malaria in Sri Lanka was a friend of mine, a demographer, Chris Langford, and I did put my thesis to him, and he read my book, and he'd looked at why tea was prevalent in certain parts of Sri Lanka and not in others. And he didn't exactly agree with me, but he couldn't see any weaknesses in the argument, and he said it sort of fitted. And later, when I looked at China, and I looked at the American Army during the Second World War produced sort of handbooks, military handbooks of China, in which they described the topography and diseases and everything about each part of China. And they did say that the area of China which would be really good for malaria, which was the central part, the very wet Yangtze, Wuhan, that sort of area, hot and wet and lots of lakes and things, was surprisingly free of malaria. And there is, if you look up tea and malaria and things on the web, you'll find quite a lot of articles now suggesting that there is something in tea, one of the many chemicals they don't understand, which gets into the gut of the mosquito and kills it. So I've spent quite a lot of my waking life trying to persuade people that they should distribute free tea to the world, and then
would beer do the same?
No.
Sadly.
Beer's no good for that, as far as I know. There are other reasons for drinking beer, but not that one.
Yeah.
Okay.
What about typhoid? Because I just wanted, I know you don't want to talk too much about it, but we've all heard of Typhoid Mary and all this lot. And I suppose I was wanting to also ask whether there are links between your work on witchcraft and these kind of stories around and disease, whether there was there anything there that kind of fed off each other?
Well, it's an interesting absence, because in the kinds of things that were attributed to witches, you would expect, since witchcraft was an explanation of pain and suffering and death and so on, you'd expect that the witchcraft, for example, accusations, the graphs I did of witchcraft would go up in years when there are known to be outbreaks of plague, which was recurrent, or typhoid or any of these others. I found no correlation at all, nor did I find any correlation with the kind of when people said, well, I think she's a witch because this has happened. They would say, you know, my cow has died, or my crops have failed, or they would say, you know, my wife died or my child died, but they wouldn't, the symptoms and so on didn't suggest they particularly picked on these kinds of things. They were just any death was a possible suspicious thing. So I didn't find that. So the last kind of disease to deal with is airborne droplet infection, which is things like measles. And I have to remind myself what the other
So these are the diseases that we used to have in the 60s.
Droplet. I mean, influenza I should have treated here, but I didn't. So, and these are basically viral and much smaller things. They're not bacteria. And therefore, it was very difficult. These were ones which were dealt with right at the end, and there was not much one could do about it. So I think that's all I need to say really about disease, except we are enormously fortunate, even though we don't feel so just at the moment. And particularly fortunate because, as not many people realize, how recent our understanding of this analytic chain is. You know, it's only less than 150 years since we understood. Before that, people were really in the dark. There were lots of cures that actually worked just by chance, various herbal and other things, or quarantine or whatever. But it was hit and miss. And what is just one of the astonishing outcomes of the COVID is how fast medicine has progressed just in the last 20, 30 years. I mean, the revolution in DNA and in sequencing, which again, a number of my friends were involved with, and one of them was coming to the fore now, Dan Brown, because he was one of the pioneers of understanding RNA, and it looks as if the RNA rather than the DNA solutions to vaccines will be a solution not only to this disease but to others. But of course, all this has just put off the problem, because what you do is you just kick the can down the road, because you don't die of these diseases through the early part of your life. You now die of the cancers and so on, which will take us neatly on, perhaps.
Yeah.
So,